In this video, I'm going to explain about optical isomerism. Optical isomerism is shown by complexes whose mirror images are non-superimposable, that is, they do not possess the plane of symmetry. Suppose this is our complex. Okay, so let's assume that we have a mirror here. This is a mirror. Then this would be the mirror image of this complex, right? Okay, so these two are non-superimposable mirror images of each other because they do not superimpose. Just take this one and try to cover this. It will not cover. Here we have AA, here we have AA. So they do not superimpose. That means they do not possess the plane of symmetry. So hence they are non-superimposable. If they are non-superimposable, that means they are optically active. They show the dextro and the levo form. Now see, if the isomer rotates the plane of polarized light to the right, then we call it dextro rotatory, and if it rotates it to the left, we call it levo rotatory, or the L form. Okay, so let us have a look at this. Now optical isomerism is shown by octahedral complexes of this type: MAA3, MAA-B2C2 and MAA2B2 type. So let us draw the optical isomers of the complexes of the type MAA3 type. Okay, this one is your symmetrical didentate ligand. So here we have the optical isomers of complexes of the type MAA3. We have the central metal atom. So there are 6 coordinate bonds: 1, 2, 3, 4, 5, 6. This is your mirror. Okay, and this would be the mirror image of this one. So here we have ear, 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 ear. Okay, so we have like this, we have like this, we have like this, and this is the mirror image. So if it is the mirror image, this one would look like this, and here it would be like this, here it would be like this. These two are non-superimposable mirror images of each other. That is, they are optically active. This one rotates the plane of polarized light to the right, so it is the D form. Okay, whereas this one rotates to the left, so it is the L form. So these are the optical isomers of complexes of the type MAA3 type. Okay, so now we come to the second type, MAA-B2C2. This one is a symmetrical didentate ligand. We have the central metal atom. We have 6 coordinate bonds. This is the mirror. We have the mirror image. We have ear, ear, B, B, C, C. So the mirror image of this one would look like this: B, C, okay, B, C, and then C, ear, ear, B. So this one would be like this, would be like this. So if you look at these two, they are non-superimposable. Try to bring and cover this one, it will not cover. So they are non-superimposable mirror images of each other. That is, they are optically active. So it has the D form and the L form. This one is your D form, this one is your L form, and this one is your mirror. Okay, so let us come to the third one, complexes of the type MAA2B2 type. Note that this one has the trans form and the cis form. The trans form do not show optical isomerism, whereas the cis form shows optical isomerism. Let us have a look at this one. We come to the trans form. Okay, in the trans form, similar groups are placed opposite to each other. So we have A, 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 A. Okay, there are two, and then B also opposite to each other. This one would look like this. So the mirror image of this one would be A, A, B, B, A, A. Okay, have a look at these. These two are superimposable to each other. If you take this one and cover this, it will completely cover it. So they are superimposable. Both are superimposable. Okay, if they are superimposable, they are optically inactive. So if they are optically inactive, they do not show optical isomerism. So we will not have the L form and the D form. Okay, that is for the trans isomer of this complex of this type. And then we also have the cis form of the complexes of this type. So in the cis form, similar groups are placed adjacent to each other, BB, and then here we have A, 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 A. They are adjacent. Okay, they are adjacent. The mirror image of this one would look B like this, and then B. Okay, and then here we have A, 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 A. This is the mirror image of this one. So if you take this one and try to superimpose, it will not be superimposed. Okay, so they are non-superimposable. They are non-superimposable. If they are non-superimposable, what does it mean? It means that they are optically active. Optically active. So if they are optically active, what happened? They have the D form and the L form, the dextro and the levo. The dextro and the levo. Okay, so how many what is the total isomers of complexes of the type Ma2B2? One is the trans form. One is the trans form. Okay, and in the cis form we have the dextro and the levo. That means there are two. So 2 for the cis and 1 for the trans. Total would be 3. So the total isomers shown by complexes of the type MAA2B2 is what? 3. That's all about the optical isomerism.